Now on to the next question. We want to find x raised to power 3 plus 1 over x raised to power 3, given that x plus 1 over x is 5. What do we need to do? We need to simplify this. We have to change this one. Don't mind me. Let me show you what we want to do. Then I would go to my page where I would easily do that. Now we will need to write this in terms of, we need to write this new thing we want to find. What is the new thing? The new thing here is x plus 1 over x raised to power 3 and raised to power 3. We need to write that in terms of x plus as we wrote it here. Some will be like, how will I do that? How will I do that? Let me show you how to do that. I'll go to a page, my writing pad. I want to show you. Don't mind me. Don't mind me. Now, I want to show you how we get now x plus 1 over x all raised to power 3. Someone will say, why do we use all raised to power 3? Don't forget in the question. This is the question here. This is the question here. We want it to be raised to the third power. That's why I'm using raised to power 3. And even they say we should raise it to the fifth power, I will use raised to power 5. And you don't forget what provision Pascal triangle made. From Pascal triangle, you get 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Are we together? So we say, how do we get this? Of course, anything raised to power 0 is 1. Then nothing this side plus 1, we get 1. 1 plus nothing 1, and nothing here 1. Nothing plus 1 here 1. 1 plus 1 2. 1 plus nothing 1. Nothing plus 1 1. 1 plus 2 3. 2 plus 1 3. 1 plus nothing 1. Then to get the fourth one, that will be nothing plus 1 1. 1 plus 3 4. 3 plus 3 6. 3 plus 1 4. Or 1 plus nothing 1. That's how we get that beautiful pattern around there for Pascal triangle. Don't mind me, don't mind the noise distraction. Now, for we to continue solving our question, I will just use the coefficient of expansion we've gotten already. And the coefficient of expansion there, is what? 1 3 3 1. 1 3 3 1. With our 1 3 3 1, and what do we get? Now, we write the right first coefficient 1 into bracket. The first term here is s. Raise it to the power we are given, 3. And the second term is what? 1 over s. Raise it to the least power, which is 0. We don't use negative stuff here. When we do anything negative, we go to that word. Plus, write the next coefficient 3. Then write the first term x. Reduce the power by 1 and increase this one by 1. The first term power will be reducing by 1. The second term will be increasing by 1. So 3 minus 1, that's 2. Into bracket 1 over x. 0 plus 1, that is 1. Plus the next one again, don't mind me, 3 x. 2 minus 1 is 1, into bracket 1 over x raised to power 1 plus 1 is 2. Plus the last one 1. I'm right, picking the coefficient one after the other. Then s raised to power 1 minus 1 is 0, into bracket 1 over x all raised to power what? 2. All raised to power 3, 3, 3. Now let me change the ink here for maybe beauty. I don't know. Now let me continue. Now with this now, for the first term, I will simplify it here, then I will write it at the next page. For the first term now, anything raised to power 0 is 1. So everything here is 1. 1 times 1 1 times s raised to power 3. Our first term is what? S raised to power 3. Plus, let's go there. Now the next one, we are here. We have something like 3x squared times 1 over x. X here 1, x here 1. So the s here 1, x here it remains 1x. So that is there. We are left with plus 3x. Now plus, don't mind my handwriting. Sorry. Now the next one, we come back to this phase. Now we have something like 3x times 1 over x squared. How do I get 1? 1 square is 1, and x raised to power 2 is what? X squared. Now this one, x in x squared, it remains 1x. So we are left with 3 times 1, 3 over x. So there we have plus 3 over x. Plus, now the last one, anything 1 is 1, anything raised by 0 is 1, 1 times 1 is 1. Then we are left with what? There we have 1 over x raised to power 3. Now we have something beautiful. Don't forget, what led to this was x plus 1 over x all raised to power 3. Someone is saying, where do we get that from? That was this here. This was what led to this whole argument. Now we'll continue with what I have. So we want to collect like them. I'm seeing s cubed plus 1 over this thing. Collecting like them, this one and this one will relate it together. I mean, this one will come and join to this. So that will be x raised to power 3 plus 1 over x raised to power 3. That's something around there. Join it together. And then I have another thing. I have a 3x plus 3 over x2. 3 over x. So at the end of the day, we can see what we have here. Simplifying this one here. Don't mind me. That will be 3 is common. So that will be 3 into bracket x plus 1 over x. So what do we have now? Let me show you the next page. Don't mind my handwriting. I'll beg you to just write it as I hear me write. Now the next thing we have there is that what we now have something like, let me change my ink, black. Okay, let me use x plus 1 over x all raised to power 3 will be x cube plus 1 over x cube, then plus 3 into brackets x plus 1 over x. What do we need? This is what we need to find in the question. So we bring this one to this side. That is our x cube plus 1 over x cube. We actually be x plus 1 over x all raised to power 3. Now this one, it is at the side of the equation on the right hand side. You want to take it to the left hand side. That will be minus 3 into bracket x plus 1 over x. So this is where we get that beautiful expression we are using. Now coming back to this, now you understand how we get this one here. Now we want to continue. So what we need to do is just to substitute. This is what we want to find. So anyway, you see x plus 1 over x, substitute 5, x plus 1 over x, substitute 5. Now this is all raised to power 3 here. So that will be x plus 1 over x, which is 5 raised to power 3, 125. And this is 3 times x plus 1 over x. Don't forget, our x plus 1 over x is what? 5. 3 times 5, 15. I bet you already get the answer, somebody. So that will be what? The answer here, from what we have here, that will be the answer here minus the answer here. So that is 125 minus 15. And somebody is saying what? That is 110. And if that was what you guessed, definitely you guessed right. So the correct answer for this question is actually 110. Next question, we want to solve the inequality 2x squared minus s minus 15 less than 0. And what do we need to do? This is the inequality we want to solve. We want to actually solve the inequality. And what do? We did this by using the completing the square method to solve. We solve the quadratic equation first. This quadratic part, this is quadratic inequality. We did as though we have equal to 0. Although it's not equal to 0, it is actually less than 0. I get what I'm saying? Although it's not equal to 0, it's actually less than 0. So we solved it as though it is equal to 0 first. Let's see what we are going to get. Are we get what I'm saying now? So solving it as though it is equal to 0, then we use the formula s equals to minus b. Using this formula, x equals to minus b plus or minus square root of the discriminant all over 2a, where the discriminant is the whole of what we have here, b squared minus 4ac. Do you remember completing the square? That will be minus b plus or minus square root of b squared minus 4ac. So instead of writing that, you can see that will be what? The discriminant all over 2a. I will get what I'm saying now. So all we need to do is just from this equation, this is our a. Let me use another ink. This is our a, our b, and our c. So our a is 2, our b is minus 1, and our c is what? Minus 15. Substituting it into this equation, I'll get b is what? Minus 1 all squared and minus 4 times 2 times this. At the end of the day, we get the discriminant to be 121. That's what we have here. How to get it now? So substituting it back, I said this is what we are using. This is what we are using. Substituting it back into this place, we get what? Minus into bracket minus, because we have minus b. Minus b, minus b, minus b, minus b. Don't forget minus b. So our minus b is going to be what? B itself is minus 1. So that will be minus 1 plus or minus square root of the discriminant, which goes to which is what? 121 over 2 times 2. Don't mind me. 2a. That will be 2 times 2. And that is 4. So we have 1 plus or minus 11 square root of 1 minus times minus here is plus. That's why we get minus times minus plus. So plus 1 is the same as 1. Then plus or minus square root of 121 11 all over 4. And with that, it will be 1 plus 11 over 4 or 1 minus 11 over 4. For 1 plus 11 over 4, 1 plus 11 is 12, 12 over 4 we got 3. And 1 minus 11 over 2 minus 10 over 4 we get minus 12 over 2. But then there is a statement, adibin it is a quadratic equation, this is where we stop it. But this is a quadratic inequality. So we have 3 regions like that. Let me show you what we mean by 3 regions. Let me show you what we mean by 3 regions. Don't mind me. Let me show you what we mean by 3 regions here. Let me show you what I mean by 3 regions here. It doesn't seem like this is functional. The 3 regions I'm talking about, I will show you here. Don't mind me. I will write on the screen here. Or should I go and use my notepad? The 3 regions. Okay, let me go and show you with my notepad. Let me show you. I'm sorry. Now, we have, when you look at the inequality now, what do we get? We get 3 and minus 5. 3 and minus 5 over 2, sorry. So we say we have minus 5 over 2 going on the number line. On the number line, you know, when you have it 0, you have the negative, and you have the positive. So minus 5 over 2 will be first, minus 5 over 2, and then you have 3 on the right. So how many regions do we have? We have region 1, we have region in between this one. Forget about the 0, the 0 shouldn't feature. Let me clean that. Let me erase that. The 0 shouldn't feature. The 0 shouldn't feature. So on my number line back, so we have points minus 5 over 2 and 3. And then we have region here. We have the region between this place, and we have the region after this place. I get what I'm saying now. Look at what I did here. That's how to get solution of inequality. So what will you do? We get, now, adibin we've used factorization. Adibin we factorize that expression. Now, what do we do? Let's say factorizing it. Let me even do it this way. That's another way. Factorizing it now. Let me go and factorize it in another slide. Then we'll come back to this. Factorizing 2x squared minus s minus 15. I guess that will be 2 times, you take the product of these two, and that is 30x squared. I want to get that here now. So of course that will be, I think, minus 6 plus 5. So that will be 2x squared minus 6s plus 5x minus 15. Don't mind me. Minus 15 minus 15. Then you bracket this and you bracket this. So at the end of the day, you have 2x in this bracket. You want to factorize what is common to this. It is 2x. Here you are left with x minus 3. Then what is common to this one too? Plus 5. Here you are left with what? X minus 3. That will be 2x plus 5 and x minus 3. So that is it. So we have 2 things there. So we have 2x plus 5. Oh, don't mind me, this thing will not be enough. I will have to make another one here too. 2x plus 5. Let me write it, don't mind me. I would not need to bracket it because I don't have too much of space. Let me leave it as 2s plus 5. Then x minus 3. But don't forget, we have 3 regions. There's a region here. These are for values less than. If you go left, you know that's less than. So we have region that is where x is less than minus 5 over 2. We have the region that is in between this place. Actually, I'm saying now, we have the region where minus 5 over 2 is less than s less than 3. And we have the region that's where s is greater than 3. I mean this region here, this is the region that is greater than 3. And what do we do? How do we get the solution of this? Think of a number that is sufficiently less than, that is within this region. Number here, that is number that is sufficiently less than minus 5 over 2. Number less than minus 5 over 2, let's just pick minus 3. You know minus 3, the more you go left, the more you go left, then the less the number. Minus 5 over 2 is the same as minus 2.5. Minus 3, minus 4, minus 5, minus 6, they are all less than this number. So let me just pick any number that is sufficiently less. Okay, let's say I pick minus 4. Put minus 4 for x here. I will get what I'm saying now. Put minus 4 for x here, minus 4 for x here. So that will be 2 times minus 4. I get a minus 8. Minus 8 plus 5. That's a minus 3. We are not really after the number, we are after the sign. There will be a minus left. Now we are putting a minus 4. Minus 4 minus 3, we have a minus there too. Minus 4. I say, let's say we pick x equals minus 4. Minus 4 for that region. Now a number within this place, that is within the range of minus 2.5 and 3. Let's say I pick 1. Let's say I pick 1. So 2 times 1, 2, plus 5, 7. Is that a positive or a negative number? You say a positive number. Okay, 1 minus 3, that's minus 3. Is that positive or negative? Negative. Okay, pick a number that is sufficiently greater than 3. Let's say I pick a 4. I want to get here. Let's say I pick a 4. 2 times 4, 8. 8 plus 5, 13. That is positive. Again, 4 minus 3, 1. That's positive. Then you don't check. What do you have? Negative times negative, positive. Because don't forget here, it is the product of the two we have. So we have to take the product of whatever it is we have there. Product of the two signs. So the product of these two signs is positive. The product of these two signs is negative. The product of these two signs is positive. So where we have positive, positive numbers are numbers that are greater than 0. Where negative numbers are numbers that are less than 0. That is why in the solution we pick the region. They said the question is actually less than 0. So which region satisfies it? This is the region that satisfies it. This is the region that satisfies it. And come and see our solution here. Come and see our solution. I'm sorry, this thing went off. Don't mind me. So the region that satisfies our answer is actually this region, the second region here. This is the region that satisfies our answer. So that is the solution to that inequality. That's minus 5 over 2, 3 is the solution to that inequality. So next one is this inequality, 3 into bracket a minus 6 less than 4 plus a. The next thing you want to do is just to what? Open the bracket. This is so simple. Opening the bracket, we have 3 times a, 3a, 3 times minus 6 minus 18. That will be less than 4 plus a. The next thing we group. Or we say isolate the variable, that is bring the variables together, then leave the constant at one side. How do you do that? Now, something about inequalities is that always ensure your variable are to the right, please. If you bring it to the left, then you need to change the sign, the inequality sign. So you don't want to do that, then always ensure your variable are to the right. So there we get 3a minus a, then bring this minus 18 to this side. So that's where we get what? Don't mind me, we delayed it, 3a minus a, that's what? 2a minus 18. So bringing the 18 to this side, now you get what? 2a equals 4 plus 18. And 2a will be what? I said equal, less than, 2a will be less than 22. And from there, divide both sides by 2. A less than 11. That's the answer to this inequality. Next up is this other inequality again. 2 into bracket x plus 2 less than 3 into bracket x plus 1 then plus 8. Like what we said before, open the bracket. 2 times s, 2s, that's what we did. Simplifying the LHS, simplifying the RHS. Now simplifying the LHS, what do we have at the left hand side? That's the LHS. 2 times s, 2s, then 2 times 2, 4. For the RHS, 3 times s, 3s, 3 times 1, 3, then plus 8. Then 3 plus 8 is what? 11. So that's how we get that. Now the inequality becomes what? 2s, LHS, RHS. But there's a less than there. So that will be 2s plus 4 less than 3s plus 11. The next thing, regroup. Whoa. Now, take a look at this. The way the solution here is going to look like. Now we have 4 less than 3x. Sorry, we are regrouping, trying to isolate s. In fact, what we should have done here, I will do it the same way. Now we are isolating. We brought, now, just by the rule of equal to, we used to say let the least relate to the greatest. Now, compare 3 to 2. Actually, 3 is greater than 2. That's why we brought this s to this side. This 2s to this side. So, with that, we have what? 4 less than 3s minus 2s plus 11. 3x minus 2x is actually x. That is 4 less than x plus 11. Definitely from there we get what? 4 minus 11 less than x. Then minus 7 less than x. If minus 7 is less than x, then s is greater than minus 7. Do we understand? S greater than minus 7. That's the answer to the inequality. To the next question, let me bring it here so that you see it. They said if a RAM costs X naira, this one here, number 15. If a RAM costs X naira and he pays 4 naira to shopkeeper, then find the range of X. Find the range of X if amount of money left to be paid is at most is less than or equal to the total amount of the RAM is X naira. He paid 40 naira. Or for him to discover that he has what? That is what? If the total amount is X naira and you pay 40 naira, how much do you have remaining? Something is X naira. Let's say something is 15 naira, I pay 40 naira. I have what? 10 naira remaining. That's 50 minus 40. So the same thing. If the total amount is X naira and I paid 40 naira, then I'm left with what? X minus 40 to pay. Now they now said we know that he can have at most 10 naira left to pay. So we said the inequality at most means what? Less than or equal to. At most is maximum, like too much. Then it may be less than that. At most, then it may be less than or equal to that thing. So that is x minus 4 is less than or equal to 10. From there, bring this s minus 40, sorry. Then bring this 40 to this side. That will be s less than or equal to 10 plus 40. From there, s less than or equal to 50. So that's the range of amount is paid. He paid something within 15 naira or less than that. That was the amount the man paid for the altogether the total amount paid for the RAM.